Guy ILS Montessori and School. Grade 9, Physics. Federal Board Islamabad, 2025 onwards syllabus. Summary of Chapter 5. Dynamics 1, from Cantab Publisher Book, Federal Board Islamabad. Chapter 3, Dynamics 1 from NBF Book, Federal Board Islamabad. Summary of Chapter. Dynamics 1. Introduction to Dynamics. Dynamics is a branch of physics that studies forces and their effects on motion. It explains how objects move or stay at rest under external influences like gravity, friction, air resistance, and thrust. For example, an object falls due to gravity, while friction slows down a sliding book. Understanding dynamics helps explain everyday phenomena and prepares students for advanced physics concepts. Mass and its measurement. Mass is the amount of matter in an object and determines its resistance to acceleration. Unlike weight, mass remains constant regardless of location. It is a scalar quantity denoted by m and measured in kilograms, kilogram. A larger object does not always have more mass. For example, an iron ball has more mass than a sponge despite being smaller. Electronic balance and its importance. An electronic balance is a precise tool used to measure mass in scientific and industrial applications. It provides quick, accurate readings and minimizes errors compared to traditional balances. Features like the Tare function allow measuring only the contents of a container by excluding its weight. How to use an electronic balance. 1. Place it on a stable surface. 2. Turn it on and let it warm up if required. 3. Use the Tare function to zero the balance. 4. Place the object on the platform and wait for a stable reading. 5. Clean after use and turn it off. Applications of electronic balance. Electronic balancers are used in laboratories for precise measurements, in pharmaceuticals for drug formulation, in manufacturing for quality control, and in education to teach scientific accuracy. Understanding and calculating weight. Mass versus weight. In daily life, we often use weight to describe how much of a substance we want, but what is actually being measured is mass, not weight. Weight is a type of force, the gravitational pull exerted on an object by a celestial body like Earth or the Moon. Unlike mass, which remains constant, weight changes depending on gravitational field strength. Weight and its calculation. Weight is a vector quantity with both magnitude and direction, always pointing toward the center of the celestial body exerting the force. It is calculated using the formula W equals mg, where m is mass and g is the gravitational field strength. On Earth, g approximately equals 9.81 meters per square second, while on the Moon, it is about 1/6 of Earth's gravity. This difference explains why astronauts appear to bounce on the Moon. Measuring weight, the force meter. Weight can be measured using a force meter, spring scale, which operates based on Hooke's law. When an object is attached, the spring extends in proportion to the force applied. This simple and portable device helps in accurately measuring weight in laboratories and fieldwork. Gravitational field strength. The gravitational field is the region around a massive body where it exerts a gravitational force. The strength of this field depends on the mass of the object creating it and the distance from its center. For example, the Sun's gravitational field is 28 times stronger than Earth's. Gravitational field strength, G, is defined as the force per unit mass and is given by G equals F divided by m. For objects in free fall, Newton's second law states that acceleration due to gravity is equivalent to gravitational field strength, equals g. On Earth's surface, this value remains 9.81 meters per square second, meaning a 1 kilogram mass experiences a gravitational force of 9.81 n. This concept establishes a direct relationship between gravitational field strength and acceleration due to gravity, helping us understand motion in gravitational fields.